All right, we're going to go over some stoichiometry using the molarity equation. Silver nitrate reacts with potassium chloride to form silver chloride and potassium nitrate. So let's first figure out this. Anytime we're doing stoichiometry, right, you need the molar ratios, which means you need a balanced chemical equation. It says that 45 milliliters of a 1.5 molar silver nitrate is added to potassium chloride. How many grams of silver chloride can be formed? So we're given this, right? It's the silver nitrate. Here it is. But ultimately, we want to figure out grams of silver chloride. So we want to end up here, and we want grams. All right, so let's figure out how many moles of silver nitrate we have first. So it says 1.5 molar equals 0.045 liters, right? 45 milliliters. This will give me this number of moles. So the moles equal 1.5 times 1.5 divided by 0.045. No, I want to multiply, just kidding. 1.5 times. All right, so eventually I get 0.0675 moles. This is of AgNO3, right? Okay, so now I have this. I know there's a 1-to-1 ratio. So for every 1 mole of AgNO3, I'm going to start running out. Let me like slant my writing so there, times. So for every 1 mole of AgNO3, there's 1 mole of AgCl. I'm going to use the molar mass of AgCl. 107.87, 143.32 grams of AgCl times 0.0675. So my final answer is going to be to 2 sig figs 9.7 grams of AgCl. Okay. All right, let's do another one. So here we have calcium nitrate, so same thing. We need a balanced chemical equation, so CaNO3 reacts with sodium carbate to form calcium carbonate plus sodium nitrate. Okay, let's make sure we balance this. It says how many liters of 0.75 solution of calcium nitrate, so we want to know liters, right? Will be required to react with 100, so we're starting with 148 grams of this, right? So 148 grams of Na2CO3. Let's go ahead and convert that into moles. (105.99 grams of Na2CO3 is going to equal 1 mole of Na2CO3. For every 1 mole of Na2CO3, there's 1 mole of calcium nitrate. So 148 divided by 105.99, so I get 1.396 moles of this calcium nitrate. Okay, so now I have the moles of calcium nitrate. I want to figure out the volume. So I'm going to use the molarity equation, right? So 0.75 molar equals 1.396 moles over the liter. So if I do that, you get around, let's see how many sig figs. We need 2, it looks like. So 1.9 liters. Okay. So basically, you're starting on one side of the equation and you're trying to get to the other so that you can solve. Here's another problem. So you got hydrochloric acid solution plus strontium hydroxide. This is a neutralization reaction. It's a double replacement where you form water plus a salt. So we got strontium chloride. All right, so we got to balance this, right? So So 525 milliliters of 0.80 hydrochloric acid is used to neutralize 315. So we have to figure out the molarity of this. So we're starting with the hydrochloric acid, and ultimately we want to figure out the molarity of the strontium hydroxide. So let's go and figure out the number of moles of hydrochloric acid. So 0.80 molar, 0.525 liters is going to get us the moles, right? So 0.8 times 0.525. So this equals 0.42 moles of HCl. So now we're going to get into strontium. So now we're going from here to here using the molar ratio, right? So for every 2 moles of HCl, there's 1 mole of strontium hydroxide. So this equals 0.21 moles of strontium hydroxide. Okay, so now we want to figure out the molarity. We have moles of strontium hydroxide. We have the volume of strontium hydroxide, so 0.21 mole over 0.315 liters. So this equals 0.67 molar of strontium hydroxide. On the next slide, I have more practice if you want. So the 3 problems we just did are the first 3 from the practice, but there's at least, I think, 9 or 10 more if you would like to practice.